Welcome to your weekly introduction videos. This week we're going to look at idea of sets and Venn diagrams. Should have come across a Venn diagram before. Sets might be something completely new to you. So what we're going to do is we're going to try and just understand definitions of terms relating to sets. It's what we call set notation. Okay, and then we're going to look at being able to represent sets in Venn diagrams. Ultimately, the goal of using them to solve problems. Okay, so just here's a little starter for you to do. We learned this quite a lot. I think I taught you this at the beginning of year 8. Let's see if you can remember how to do this. So find the highest common factor and lowest common multiple of 2,100 and 1,470. And you just a hint, remember it uses Venn diagrams. Okay, so stop your video and see if you can do it on your own first. Okay, hopefully you did that. What you have to do, if you remember, you have to do prime factor decomposition. So you need that prime factor tree for both numbers. So we're going to do 2,100. That would be 10 and 210. Is 10 a prime number? No. So 5 and 2. Okay, 5 is a prime number. 2 is a prime number. Okay, we can go 21 and 10 again. 21 a prime number? No. What about 7 and 3? Well, 7 and 3 are prime numbers. And 10 is not a prime number, so let's go 5 and 2. Again, so 2,100 can be written as a product of prime factors. 2 times 2 times 3 times 5 times 5 times 7. Okay, right, what about 1,470? Well, again, we can certainly do 10 and 147. 10 is not a prime number, but it is 5 and 2 are. Okay, 147, well, 2 doesn't work. What about 3? 3 will work. Yeah, we can divide 3 into 147. Let's just do that. 3 into 147. Well, 3 into 1 doesn't go. 3 into 14 goes 4 times with 2. It's 49, isn't it? Okay, so 3 and 49. And in 49, hopefully you recognise as 7 and 7. So 1,470 can be written as a product of prime numbers. 2 times 3 times 5 times 7 times 7. Okay, and now we're going to make Venn diagrams. So we need 2 circles. And 2,100 will represent one of the circles. And 1,470 will represent the other circle. And in the middle, we put what we can share. So I can share 1, 2. Okay, 1, 2 appears in both lists. So I'll put a 2 in the middle there. I can share a 3. Okay, so I'm going to put that 3 in the middle there. I can share a 5. So I'm going to put that 5 in the middle there. And I can share a 7. So we'll put that 7 in the middle as well. Okay, now what am I left with? In 2,100, I'm left with a 2 and a 5. And with the 1,470, I'm left with a 7. Okay, so now we can do the highest common factor. If you remember, it's all of the numbers in the middle multiplied together. So 2 times 3 times 5 times 7. See if I can do that in my head. 6 times 5 is 30. 30 times 7 is going to be 210. The lowest common multiple is all the numbers that you can see multiplied together. So it's 2 times 3 times 7 times 5 times 2 times 5 times 7. Well, that's going to be 210 times 10 times 7. Let's see if I can do this quick. That's going to be 2,100 times 7. What's 7 times 21? That's 147. So I think that's 14,700. I think would be the lowest common multiple. I've just done that quick. Actually, I might have made mistakes. So if I have, please let me know. Okay, but as I say, I taught you that quite some time ago. So hopefully you could remember that. You've seen there practical use of Venn diagrams. Okay, so just bear that in mind for when we get going with this topic. Okay, now what we're actually going to be looking at is this idea of a set. Okay, now a set is just a collection of numbers or objects. Okay, and what we say is each object is an element of the set. Okay, I use the word element, not member. So for example, your maths group, year 10, set 1, whatever you want to call it, is a set. And we could say that each of you are elements of that set. And there's 21 of you in the class, so there are 21 elements in the set. So the way I could write this, I might say something like this. X is students in year 10, set 1. Okay? And what I do is I write it like this. X is equal to, and then I use these kind of funny brackets here, and I can list all the elements of the set. So I could say Attica is a member of the set. Farah is a member of the set. Mohammed B is a member of the set, and I can list out all 21 members of the set. Okay? I might get a set where I'm going to say A is prime numbers less than 20. Prime numbers less than 20. So I can write all of those out. So A is 2 is a prime number, 3 is a prime number, 5 is a prime number, 7 is a prime number, 11, 13, 17, and 19. Okay, so there's my set A, all the prime numbers less than 20. Okay? So that's how you write out a set. You know, you can make a set of anything. You could do days of the week. Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, Sunday. Months of the year. You can make sets about anything you like. Okay? Now, this funny little squiggle here, this one, this means it belongs to or is an element of. So we could say something like, just make the right space. We could say something like, because if you remember, we said X is students in year 10, set 1. We could say Lena belongs to X. Okay? It means Lena is an element of set X. Okay? We could say something like this. Mr. Simon is not a member of set X. Because if you remember, what I said was X is students in year 10, set 1. I'm not a student, I'm a teacher. So I don't belong in that set. We could say that the number of elements in set X is 21. Okay, so this N means the number of elements. Okay, so for example, if we're saying set B is days of the week, then the number of elements in that set is equal to 7. Okay, so hopefully that makes sense. So we've got elements and we've got numbers of elements within a set as well. And you need to be able to know the difference. Okay, this is just a bit of English language for you. Set A is a finite set if the number of elements in the set has a particular value. So, for example, I just said days of the week, and I said that was equal to 7, right? So that's a finite set. There are only 7 days in the week. There aren't more. The list doesn't go on forever and ever and ever. Let's say I define set C as all numbers, all integers. All integers, so, like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Well, this is called an infinite set because we can't count them. Okay, we can't count that set. We just go on forever and ever and ever and ever and ever. So, the number in C is who knows. Okay, so that would be an infinite set. Okay, now let's just go through what these particular things mean. So set A is a subset of set B if every element of A is also an element of B. Okay, so let me give you an example of what that means. Let's say, remember we had set B was days of the week. Days of the week. Okay, and let's say set D is days of the weekend. Okay, so B is equal to, let's just use letters, Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, Sunday. Okay, and set D, since we're in Oman, the weekend is Friday and Saturday. Okay, we can see that all the elements of set D are also in set B. So this means D is a subset of B. D is a subset of B. All of the things that are in D are also in B. Okay, all of the things that are in D are also in B. So that means we've got a subset. Okay, so we need to be able to know what that means. The empty set is just a set that contains no elements. So maybe we've got set E is all people who like Mr. Simon. Okay, and nobody likes Mr. Simon, so E equals empty. Okay, so this is how we represent when there's nothing in the set. So I'm very sad, nobody likes me, I'm an empty set. Okay, the universal set is all the elements that we are considering. Okay, now that doesn't mean universal is that we can throw everything and anything into that set. We can tailor what the universal set is depending on the problem. So remember, set A was Year 10 set 1 students. Then perhaps the universal set is all TSS students. Okay, so U basically just defines all of the elements that we need to consider, and we make up what that is depending on the problem that we have, okay, to help us solve that problem. So it can change, the universal set can change from problem to problem. Okay, so here are some questions for you to do. Very easy, I hope. So stop the video and see if you can do them, and then start again and I'll show you the answers. Okay, so hopefully you've done that. Let P be the set of all multiples of 6 less than 20. Q be the set of all even numbers less than 20. So we're going to say P is equal to, do it properly, multiples of 6 less than 20. Now I assume that U means all positive numbers, otherwise we could be here all year. So we're going to say 6, 12, 18. And we stop there because otherwise I'm going to go above 20. Q is even numbers less than 20. 2, 4, 6, 8, 10, 12, 14, 18. That will be it. We can't go to 20 because we said less than 20. I also didn't include 0, which is an even number, because I'm just assuming they meant positive numbers, but I didn't say that. So there we go. I've listed all the elements of P and all the elements of Q. So, true or false? 10 belongs to P. That's false. It doesn't. 10 does not belong to Q. False again. Okay, because 10 does belong to Q. 12 belongs to P. That is true. Okay. Find the number of elements of P. Well, there's 3. 1, 2, 3 elements of P. The number of elements of Q. 1, 2, 3, 4, 5, 6, 7, 8. Okay? Right. Now, D says, is P a subset of Q? So what we need to do is say, are all the things in P also in Q? 6 is, 12 is, 18 is. So it is true. It is true that P is a subset of Q. Okay, so I hope this is all making sense. Of course, if it's not,